Welcome all to this fifth lecture in Earth Sciences Week 2020. Now I request Dr. Ajit Vartak to introduce Dr. Ian McKay sir from South Africa. Dr. Ajit Vartak.
Good evening, everyone. It is a great pleasure for me to introduce our speaker today, Dr. Ian McKay, who is going to talk about geoheritage in South Africa. Today we are celebrating Geoheritage Day. Dr. Ian has PhD from Witwatersrand University. Title of thesis was Cretaceous Carabidi and Paleo-Environment of Orapa, Botswana, where he described a unique fauna of fossil beetles and reconstructed an environment from the time of the dinosaurs. One of the fossil beetles has modern relatives which are only found on the northwest coast of North America and the Cape of South Africa. He did higher diploma in education and MBA from the same university. Ian McKay is an education and outreach specialist for the Center of Excellence in Paleosciences and Evolutionary Studies, Institute of University of Witwatersrand. He is passionate about involving the public in paleontology with his outreach program called Paleontology for All. Ian has over 24 years of experience in education and public engagement of science. Ian is also one of the South African Council members for the International Geosciences Education Organization. He was the convener of 6th Quadrennial Conference of the International Geoscience Education Organization, which was held in 2010, which was attended by more than 200 delegates from 35 countries. With this short introduction, now I request Dr. Ian to deliver his talk, Traveling Through Time, Exploring Geoheritage in South Africa. Ian.
Hi, good evening, everybody, and thank you very much for allowing me to come and speak to you. I'm very afraid because there's so many experts in the audience, and this really isn't an expert sort of talk. So my first question to you as the audience, and it's a pity that we weren't face to face because then maybe we could discuss some of these questions, and that is time travel possible? I was just for fun, I Googled time travel on the internet, and there's so many stories about people who claim to have traveled backwards and forwards in time and all the things that they saw. And of course, astronomers, in a very real and non-hoaxy way, can time travel just by looking at light from a distant planet. They can see what was happening on a star, how that star was millions of years ago when the light first left that star. But for us geologists, we can also time travel. And of course, the way we do it is by looking at rocks. Now, I wonder how many of you experts out there can identify this particular rock. Can you? I suppose we can't really talk, but it's actually rhyolite. And if we did the chemical tests and we examined it and we know it's a rhyolite, then we know that it's a very silica-rich lava. And if we could go back in time to when that rock was formed, we'd see an erupting volcano and all this very, very, very thick lava come flowing out, turning solid and forming rhyolite. Now, when I was doing the research for this little talk, I was very interested to find out that rhyolite was named by, and I don't know if you know the story, but by the famous Red Baron, who was this World War I fighter ace who made more than 40 kills, Manfred van Richthofen, and he was actually a geologist, which is kind of surprising. So if you're a geologist, maybe you also have the makings of a fighter ace. Now, my project has sort of built out of about 5 years of work where we have prepared a traveling exhibition, which we call the Maze of Time. And we travel around the country to big shows. It's got more than 40 posters, which cover time from the Big Bang to kind of recent times, all based on South Africa. And we talk about the age of the Earth. How do we know how old the Earth was? And what it was like if you could travel back in time 252 million years ago, 600 million years, whatever. So basically, by visiting our exhibition, you get a chance to play the part of a time traveler. And to make our exhibition a little bit more attractive to the public, we've got dinosaurs, we've got fossils on display, or casts of fossils, large paintings. We kind of build caves to really make it as interactive and nice as possible for the public. And then we have our postgrad students from the Evolutionary Studies Institute at Wits that come out and spend their time talking to school kids and members of the public. Or if we go to other parts of the country, we have staff from the museums that assist us, or postgrads from the other universities. So it really has been a fun thing to do. And we have seen almost 1 million people over the last couple of years that have passed through our exhibition, more or less, because we don't keep a register, but we do know how many people visit the exhibitions and more or less how many of them come through to our particular exhibition. So the big idea that we had this year before the lockdown was that we do a good job of showing people fossils and rocks and what it was like in the past, but we don't really tell them where they can go and see these things for themselves. So that's what we decided to do, to expand our exhibition to include sites where you can go and see rocks that tell you what it was like a long time ago. So around the country, there's special places. Some of them are sacred, of religious significance. Others are historical, like old mines. Many of them are, and of course, all of them are of scientific interest, I should mention, with rocks and fossils that need to be preserved and tell an interesting story. So these are geoheritage sites. In South Africa, we have over 20, depending on how you kind of define one of these sites. And in India, I found a newspaper article that said you have 32, but I'm sure you must have more than that, many more. And also in South Africa and in India, we've got natural history museums, national monuments, and geotrails, which also preserve and display our geological heritage. The thing is, in South Africa, and Ajit was telling me that in India it's the same, these places are not well known to the public. If they are thinking of something that they want to do on the weekend or just in their spare time, they don't usually go to a museum or a geotrail or a monument. And so our geoheritage sites don't receive a lot of attention, which means that they aren't properly looked after. And it also means that they aren't creating the jobs that they could create if they were properly supported by the public. So the aim of our Time Trip project is really to help advertise our wonderful geoheritage sites to all South Africans by traveling it around the country in the same way as we do for our Maze of Time. So we started off by saying that we would just create one annual poster for each of the 20 sites, natural history museums, and to add that to the Maze of Time exhibition. But then COVID happened, so we decided that we would expand it, and we're going to also create a website that provides the same information where public can come and download the posters, as well as get extra information. And what we're also going to do is to link the posters and the websites to the websites of the geoheritage sites and museums, if they have some, so people can go and click through and find out how much it will cost to visit that place, when it's open, and all the rest of it. We're not going to have that information on our exhibition because it changes all the time, and we can't update our posters every time somebody changes their visitors' hours. So what I'm going to do now for the rest of the talk is just to introduce you to a few of the geoheritage sites that we've got. All right, but before we start the talk, I want to introduce you to this lovely slice of cake, because by looking at that cake, you can tell, as just an ordinary person, if you've ever baked a cake, that that layer is older than that layer and that layer and that layer. So as you move up through the layers of cake, you're moving from the oldest to the youngest. And so that is exactly the way it works in geology. We have layers of rock at the bottom, which are usually older than the ones at the top. Of course, they do get moved around sometimes, which does confuse things. But usually the oldest layers are the ones that are found at the bottom. So this here is a geological column of South Africa. And just like the cake over there, you can see there a whole bunch of different colors, and each color represents a different age of rock. Okay, so, I think, let me just get back to this slide. And what I'm going to take you through are 7 sites from the very oldest to the very youngest today, just quickly to show you what kind of things we have there, what our hopes and dreams are for the place, and how we can read the rocks to tell an interesting story about what life was way back then. So the first site that we're going to look at, starting at the very oldest, I don't know, if you were a time traveler, would you go from the present to the past, or would you go from the past to the present? I somehow feel, and I don't know if it's how geologists think, that we always start with the oldest and we work upward to the youngest. So we are going back 3,500 million years, or between 3.2 and 3.6 billion years. This is in the eastern part of our country, in a place called Barberton. Very, very beautiful, as you can see. And yeah, we have a very awesome geoheritage site. So if you go to this geoheritage site, you'll get a chance to explore 12 moments in time between 3.2 and 3.6 billion years ago. Remember, a billion is 1,000 million. You'll visit 12 stops as you drive 37 kilometers through some of the most stunning scenery on Earth. Each stop has beautiful signs that explain what that place was like thousands of millions of years ago. And how do we know? By reading the stories in the surrounding rocks. So, as I said, it's in Mpumalanga, South Africa, in the Barberton Makhonjwa UNESCO National Heritage Site, World Heritage Site, actually. And if you drive along that road, there's the most gorgeous scenery. You can drive yourself, or you can take a guide. And the guide obviously will explain to you in much more detail what's going on there. There's also a nice guidebook that you can read to sort of, if you want to do it by yourself. And the signs are really nice. They've got wonderful graphics, very well thought out. And some of the things you can see are a 3.2 billion year old ancient beach with some of the earliest signs of life on it. I mean, with some algae, actually. I'll show you a rock just now. Some of the earliest signs of life on Earth are also found in this area. And they were bacteria that lived in springs, in hot springs, on the sea bottom, and in the seawater. Also, there are the remains of ancient volcanoes with superhot lava that was erupting at the time, and beautiful striped ironstones, banded irons, indicating that the oceans were becoming oxygen rich. And the whole area around the town of Barberton has got a rich history of gold mining, where they've been mining there since 1874. This is a reconstruction over here, this painting on the left, of what the area would have looked like way back then by the artist Maggie Newman. You can see the volcanoes there erupting, and I'll explain to you later why the lava was hotter than the lava that we have today. The moon at the time was closer to the Earth and larger. And in the foreground here, you see these domes, ancient cyanobacteria. And at the time as well, we were being constantly bombarded by meteorites because the solar system was still young and the area in space was still full of asteroids floating around, which were getting attracted out and raining down on planets as they were forming. And at the bottom, and I don't know if you can see it, but you can look at the slides afterwards, there's a website that you can contact if you want to find out more about the place, maybe to go and visit it, or just for your own interest. Maybe there's something here in India that is similar to this. All right, so just some of the sites that you can. This is an ancient beach, and you can see these carbon-rich layers in, I think it's a very fine sandstone, which were once actually cyanobacteria or bacteria, layers of bacteria that have become formed into carbon on like an ancient beach, an ancient shoreline. And here you can see a sandstone with a cross bedding that they think was actually formed by the action of tides. So again, an ancient beach about 3,200 million years ago, or an ancient shoreline, which is pretty fantastic if you think about it. And then I was talking about superhot volcanoes. Well, way back then, the Earth was still cooling down. So the volcanic lava at the time was a couple of 100 degrees Celsius hotter than volcanic lava today, around about 1600 degrees Celsius. And the lava from the shield volcanoes in Hawaii, and there's one over on the left, I think is about 1250, 1,000 to 1,250. And if you travel through the road, you can see pillow lavas, which were formed when lava flows into the ocean. And yeah, these tiny little clasts were like volcanic hail, mini volcanic bombs that rained down on the area and formed thick layers. And then you get beautiful banded iron formations. So in the oceans of the time, where there was not much oxygen, so oxygen was still increasing in concentration, all the oxygen was soluble in the water. And then as oxygen levels increased in the atmosphere, dissolved in the ocean, that oxygen combined with the iron, forming these insoluble red layers, which are being mined in the Northern Cape of South Africa today. This is Sishen. And this is all this huge pit. That's what they're mining there, banded ironstone. So I know in South Africa and I'm sure in other parts of the world, banded ironstone is really important economically. Oh, I'm showing you what you're going to see. All right, so our next stop is the Witwatersrand, which we were just talking about just now. So there, the Witwatersrand is over there at the end of that arrow, that little area, but also all the bright red areas on the map of Witwatersrand, of the Witwatersrand. And we're talking about 2.8 billion years old. And I'll tell you a little bit more about the Witwatersrand in the next couple of slides. But if you wanted to see the Witwatersrand today, it's an area that's been incredibly mined out. Unfortunately, though, either the mines are working or they've been closed down. And there is only one that is still open to the public, a National Heritage Site. And this actually is in a pleasure park called Gold Reef City. So you can go down the mine and you can travel on a roller coaster. And it's right in the center of town. So this is a proper urban geoheritage site. And this is the headgear of the mine. And so it's actually the number 14 shaft of Crown Mines. It operated between 1897 and 1977, extending to a depth of 3,293 meters. It was once the deepest mine in the world, operated by 30,000 workers, and apparently produced 1.4 million kilograms of gold in its time. So it's actually a pretty significant site, but I still think it's sad that there's only one mine left where you, if you're interested in this kind of thing, where you can go and visit. And it's, well, as I said, in a pleasure park. Now, it's in Johannesburg, South Africa. And what do? If you visit the place, you put on a helmet and a lamp. They've got a cage, which is basically a creaky mining lift, and you go down 220 meters. The mine, that shaft itself goes down a couple of thousand more meters, but it's been flooded out. So you can only go down 220 meters. And then when you're there, you walk down a tunnel with your little lamp and your helmet, and they start up a mining drill. And for those of you that haven't been down a mine, they're incredibly noisy things. And if you weren't wearing earplugs, you'd soon go deaf. And they've got a reconstruction of the mine manager's office. And you can also view gold be melted and poured. And their favorite thing is to get a gold bar like the one in the illustration in the background and tell you that if you can pick it up, you can take it home with you. The problem though is getting a grip, and it's incredibly heavy as well. So the two together, I don't think anybody, no matter how strong they were, has managed to make off with the gold bar. And they also have a gold mine museum there that you can go and visit. So by South African standards, it's a bit expensive, but it really is worth a good visit. And there is a website there as well at the bottom if you want to find out more. All right, so now, what was the Witwatersrand like 2.9 billion years ago? This is another illustration by Maggie Newman. And you can just see in the background, there were these low hills, it was granite, there was the shallow sea, and basically that gold had, those hills of granite had gold or greenstones as well, had gold and uranium in there. It was being washed into the sea and concentrated in the sediments where it could be mined. So Witwatersrand, I've used that word many times. It means whitewater ridge. And gold was discovered in the Witwatersrand in 1886. It's the richest gold field ever, producing about 52 million kilograms of gold, or 30% of the gold ever extracted. And there are still 30 million tons of gold in the field, but they're very deep. And so at the moment, it's not economical to extract most of them. They're also reworking the tailings dams, the mine dumps that still have that were left behind by the gold mining, which still have small amounts of gold in them, which are actually worthwhile extracting. This area has the deepest mines in the world, operating at depths of 3.8 kilometers. And in the 1970s, it produced 80% of the world's gold, but today only 8%. And here a nice piece of Witwatersrand conglomerate is. You can kind of see the pebbles there. And so, and with these, a lot of pyrite in there, and also some fool's gold. And just to sort of say, so these hills at the background would have been granite and greenstones, and then the pebbles and the sediments from these hills would have been washed out into the sea to form alluvial fans, and the gold and the conglomerates were concentrated in there because the gold's of a high density. That's why you get such rich gold deposits in those fans. All right, so the next stop, now we're going up here. Where's my cursor gone? About 2,000 million years ago, or 2 billion years ago, and it's the Vredefort Dome. All right, so I think just have a look at this geological map. Can you see that circular structure there? I'll show it to you again in close up. There you can see this very circular structure on the geological map, quite odd. Well, originally they thought it was sort of a super volcano that created that circular structure. And from the outer ring there to the center is 300 kilometers. This central part is about 90 kilometers across. And if you look at that central part now with an aerial photograph, you can quite clearly see the circular structure there. And this site is huge, and you can spend the day traveling from place to place in it, looking at the evidence which geologists discovered that indicated it wasn't formed by a huge volcano, but rather by the impact of a giant meteorite. You can also visit the impact exhibit in the nearby Vredefort Museum. So this is actually the remains of an impact structure formed by a gigantic meteorite that struck the Earth about 2 billion years ago. So in South Africa, it's found at the intersection of 3 provinces, and it's actually the Vredefort Dome World Heritage Site, UNESCO World Heritage Site. And when you read about these meteorites, and I'm sure you have, they are just, the facts about them are so astounding. So this meteorite was probably about 10 kilometers wide and traveling at a speed of 300,000 kilometers per hour. It's a good thing it struck the Earth 2 billion years ago, or it would have been a disaster. And then it's been estimated that it made a 40-kilometer deep dent in the Earth, which rebounded to form a crater. And so that rebound actually resulted, instead of a crater, I mean, which you think of as a dent, but it actually formed a dome in the center. So it was kind of like a whole rebound structure. And that's why it's called the Vredefort Dome. And that crater itself was about 300 kilometers in diameter. So for me to drive from Johannesburg to Vredefort is about 2 hours, I think. But if I go to our nearby botanical gardens, you can actually see how the sediments have all been inclined. And they were inclined and they dip because of that meteorite impact 300 kilometers away 2 billion years ago, which is kind of really scary if you think about that. It was really a mega event. And this is still the largest and earliest impact crater, as far as I know, on Earth. All right, and what sort of evidence did they find that told them about that proved that this was a meteorite and not a volcanic crater? Well, you can see these what would you, Christmas tree shapes in the rocks, right? Called shatter cones. And apparently under very high pressures and temperatures, the crystal structure of the rock rearranges itself and forms this kind of Christmas tree structure. And the only other place on Earth where you find these, other than meteorite impacts, is in nuclear test sites. And then, yeah, this was the granite of the area, which was just simply shattered. And some of it was, and partially melted. So you get these huge fragments of broken rock with the fine melted material in between. So this is the kind of evidence that they use to prove that this is not a meteorite, and I mean, not a volcano, but a meteorite. And it's only recent. These are discoveries of the last 30 years or so, made by geologists at my university. All right, now we're going to take a huge jump. We're going all the way from down there to there. Okay, so when I was putting together this presentation, I actually realized that there's quite a large bit of the geological column that we need to have some heritage sites at, because there's this huge gap in time. So now we're going to go and see a 360 million year old lagoon or estuary from a town called Makhanda, which is down there in South Africa, near the coast, in the Eastern Cape. All right, and this is what it looks like today. It's work in progress. And it's actually a pretty ugly site, isn't it? Right on the highway. But what's special about it is that when they were building the highway, they were sort of excavating the sediments away to make room for the road, and also possibly to use in the building of the road. And this is actually going to become a picnic spot. Because in those sediments, there are the most fantastic fossils that I'm going to tell you about. So the aim is to have a nice picnic site, plus a little display area with signage so people can take their lunches there. And while they're having their lunch, learn about this ancient site 360 million years ago. This is what it looked like, more or less, 360 million years ago. It's found in our Eastern Cape. And why is it special? Well, it actually preserves the oldest land animal life in the Southern Hemisphere. I should put terrestrial animal life, okay? And what makes it special is that this area was actually quite close to the South Pole back there. So at the bottom, there's a map. That's the South Pole. And this is where the site is. Now, there are other 360 million year old sites in other parts of the world. This is the Devonian period, right? But this is the only one that's located close to the poles. The others are pretty tropical. So let's have a look. What sort of fossils are there? If we were interacting, I could ask you what this is. And this is a very, very fine pretty metamorphosed, almost a slate, and it's quite shiny if you see it in real life. And you get these tiny little creatures preserved. So I'd leave you to imagine what that might be. And actually, it's a fossilized lamprey or hagfish. These little suckerfish, it's only a couple of centimeters long, and you can see very clearly, I hope, if I could show you, there you can see this little rosette of teeth. So this would have attached itself to another fish and just hung around there, sucking its blood. So that's a pretty amazing discovery. Who would have thought these are cartilaginous fish? Who would have thought that this soft-bodied creature would be preserved in such detail? And yeah, we have some, you can see those are leaves. It's an early tree called Archaeopterus. And this is what they looked like back then. So 360 million years ago, you already had pretty large trees, but these had spores and not seeds like the ones we have today. And they really were the first large trees, as far as I know, that appeared on Earth. And here, this is like, what is this thing, right? You might wonder, actually, it's one of the shoulder bones of an animal called Tutusius. And what's special about it was it's like a Canthostega or Ichthyostega, a lobopod, a fish with legs, lungs, and gills. And so this was just at the time when tetrapods were moving onto land, and these are thought to be the very first kind of amphibious duel. They might have been in shallow water, around the shorelines, able to breathe in air, and they are thought to be the ancestors of tetrapods. So again, this is a pretty fantastic find from South Africa, because these are the only ones known from a site that is close to the South Pole, from the temperate regions, where all the others were kind of equatorial ones. And this is my favorite one, because I'm interested in insects. It's not an insect, but can you see what it is? It's like a pinsea. What do you think that thing is there? A scorpion. So this is the earliest land animal from Gondwana land, and it's a little scorpion. There are older scorpions from the northern hemisphere, from the Silurian, way before then, but this is the first one from our part of the world. Isn't it beautifully preserved? All right, and this is more or less what the scene looked like. There you've got your Archaeopterus trees at the background, and your club mosses, and you've got seaweed in the water. You've got these four-legged fish swimming around. Those are little coelacanths, and those are placoderms, large armored fish. So research in this area is producing all these wonderful fossils, and I think people are really going to enjoy having a picnic and looking and learning about this ancient place. Now we come up to a project of our university that I've been involved with for a long time, and it's the Kitching Fossil Exploration Center. So we're going from 360 million years ago to 255 million years ago. So we're moving up from there to there. And this is what the area looks today. A beautiful, tiny little and a very poor town in the Eastern Cape. And Kitching, James Kitching was a paleontologist that grew up in that area and became really world famous for his ability to find these fossils in the Karoo. He even traveled to Antarctica in 1972 and found similar fossils in the Antarctic to the Karoo, of course demonstrating that the continents were joined way back then. And this was at a time when there was still a bit of debate about plate tectonics. So we set up this little site to commemorate him and to preserve the fossils that are still there, and also to create employment in New Bethesda. So if you were to travel there, you could spend time there. There are lots of other activities too. and you could take a guided tour of our small exhibition center, watch fossils being prepared, and also look for real fossils in the riverbed. And also learn to imagine what this place looked like 255 million years ago. So this is what the riverbed looks like today. There's still quite a few fossils there. And our little exhibition center is in the town at the background, in the back. You can see it's hot and dry and arid. So, but if you visit it, we have guides from the local community. We're trying to create jobs as well in this poor area. So they'll take you on a tour of about an hour. They take you to the exhibition center, and you see a demonstration of fossil preparation, how you get fossils out of the rock, and also see real fossils in the riverbed. This is our little exhibition center. It's basically really in a house. And during the holidays, we have this inflatable dinosaur that we put up there. And it was during the Christmas season, hence the decorations on these animals here. And this is Melanie, one of the guides. And she's got an Airscrabia, and she's really showing tourists how you really use this compressed air dentistry kind of thing to remove the matrix and leave the fossils behind. So you can actually see this fossil emerging from the rock. And this is Gerrit in the riverbed, and he's showing these tourists here. And there, if you look carefully, you can see that's a beast called an Aunulla Cathedral, and that's part of its skull sticking out there, and this is it in close-up. So those are actually real bones. And he asks them to imagine what the area was like, and he asks them which is the skull and which is the tail and which way was it facing. And so he kind of interacts, and we really have good reports from the tourists that visit the place. This is what the riverbed looks like today. After a bit of rain, it's got water in it. Luckily, it doesn't seem to damage the fossils much. And that is what it looked like 255 million years ago. Where is it gone? So there you can see today and back then. So there were these huge rivers, and they were really big, flowing from the Cape Mountains, which were the size of the Himalayas back then. They were prehistoric Glossopteris trees, horsetails, ferns, and these mammal ancestors here. Gorgonopsians were the predators. These Aulocephalons were like the herbivores, like the antelope of today. And these are sort of, where is it going? A pariasaur. So you're getting an idea of all the different types of animals that were living back then. And we're talking at about a time 50 million years before the dinosaurs, therapsids. These are mammal ancestors and not at all related to the dinosaurs, which is a fact that many people find quite astounding, that there were animals living before the dinosaurs. Right, now we're going to jump even further up into the Cenozoic. We're going there on the west coast, and this is the West Coast Fossil Park. Now, this fossil park had its origins in a phosphate mine. So during the 60s and the 70s, there was a huge pit here, and they were extracting all the rocks because they were rich in phosphate, which, as you know, is used in fertilizers and things like that. Since then, it has become rehabilitated, and now it looks like, well, let me tell you a bit about it, right? So it's an old phosphate mine, the West Coast Fossil Park. It's incredibly rich in fossils, and I'll show you just now how rich it is. Basically, there's a bone bed, wall-to-wall in fossils, and there's a modern visitor center, which explains it all. And the bones tell of a warmer time, 5 million years ago, when bears and wolverines roamed Africa. And these are animals that we don't find in our continent anymore. Now, let me show you what it looks like today. Big difference, huh? Beautifully rehabilitated. All these flowers. And yeah, another thing is, obviously this is the flower season. Many times there are not flowers there. So where is it? In South Africa's Western Cape province, and the highlights are the bone bed that I'll show you. It's just fantastic, mind-boggling. They have a beautiful up-to-date visitor center now that was built 2 years ago. And as you can see, the fynbos vegetation, which is so rich in endemic species, is actually quite beautiful well, if you go at the right season, it can be quite dry, but it really is beautiful any time of the year. So this is the bone bed. It looks a bit like a, what would you call it? A greenhouse. But if you go in there, there are these walkways, and the ground is just completely and utterly littered with bones, concentrated bones. And I'll show you a close-up. See how densely they're packed. They were sort of packed by river action in this estuary. That's why they're so concentrated. And you get kind of a combination of sort of civethias, which were kind of like giraffes, and whales, and bears, and fish. So you're getting a whole combination of marine, river, and terrestrial animals all together in this thick, thick bed, which has really revealed so many interesting things. And when you see it in person, it's fantastic. Of course, this has been carefully prepared, quite a process. They had to take those airscrabs I was telling you about and portable compressors and carefully work away at the sediments to remove and show the bones. Many years of work here. This is the visitor center. And inside it's very arty. So it's very arty. They've got these sculptures. These are civethias, kind of giraffe-like creatures. These are these hyper-realistic airbrush scenes of what it was like. Hippos, a little bit of the estuary. Really nice and pretty impressive if you go there. They also have these education programs there. And you can see the kids are digging from a fossil dig. And here they're looking at little owl pellets and things like that. So this is what the area looks like today. Really not so many flowers. Oh, sorry, I've got my phone going here. Okay, so yeah, the fynbos is today with some antelope in it. This is what it would have looked like 5 million years ago or so. Yeah, it's an African bear, a bush pig, a wolverine, a hyena, a white rhino. Those are apparently relatives of nilgai, which come from India, I think. Proteas, some vultures, thickly vegetated. So you can see it's actually completely different. It was much warmer back then than it is today. And all these interesting animals, bears we don't find on the African continent anymore. Wolverines, not either. At the time, today there's actually a cold current flowing down the west coast of South Africa. This was a time before that cold current was flowing. That's why it was so much warmer back then. Now, for our last stop, which is the Cradle of Humankind. And very recent, but it also has very old rocks as well, which tell an interesting story. Situated, well, it's actually quite, it's a World Heritage Site with 3 parts, but the main part is situated around the Northwest Province and in Gauteng, South Africa. Another place that has its foundations in mining. So actually, there was a lot of mining in back in the early 20th century because lime, that is, because lime was used to in the process of gold mining, to refine the gold. So there was this huge search for lime to sort of keep the gold mines going. And so they started mining lime caves in the area with these stalagmites and stalactites and their travertine for the lime. And they built these lime kilns. These are lime kilns in the eastern part of our country. And this one here is from the Cradle of Humankind. And of course, while they were searching for the lime, they came across all these fantastic fossils that I'll tell you a little bit more about, of human ancestors, for example. But the rocks themselves tell the story of a 2.2 billion year old sea with oxygen producing cyanobacteria. So why don't we start with the rocks, the 2.2 billion year old rocks. So this is dolomite. It's got this kind of etching on its surface, which reminds people of an elephant skin. So it's called elephant skin weathering. And calcium, magnesium carbonate. But way back then, 2.2 billion years ago, it was a shallow sea, and there were all these domes of cyanobacteria in them, producing oxygen, interestingly enough, but photosynthesizing. And those are what have become preserved as dolomite. If you look at some of them, you can still see the domes, that dome structure in the dolomite. And this dolomite became eroded away or weathered and weathered by the acid rain to form the caves that the animals and human ancestors later fell into to become preserved as fossils. So where is it? As I said, in the Cradle of Humankind World Heritage Site, in the central part of our country. And the highlights are, I think the real highlight for anybody is that 3/4-hour tour of the Stagfontaine Caves, which is actually only one of many fossiliferous sites in the Cradle of Humankind. But there you can see, you get a feel for how the fossils, how the animals got trapped in there, how they became fossilized, and see a couple of places where famous fossils have been found. They also have now, since 2005, a nice modern up-to-date visitor center, and they're actually redoing the displays for that as well. And the Cradle of Humankind is a beautiful place just in its own right, a nice place to visit. So this is Stagfontaine Caves, and there you can see a party of tourists, 3/4 hour, you need to wear helmets, and you can see that this has all been mined out, but once it would have been all stalagmites and stalactites and travertine, and people are fascinated as well by the shapes that are preserved in the rocks. You can see the underground water, there's underground water there, and you can see, again, the flowstone on the surface of the rock that's rich in lime, mostly removed now. But it really is a very nice and authentic experience as a tourist to go down that cave. This is the Moropeng Visitor Center. This is the Tumulus building. And you can see the nice, beautiful Cradle of Humankind, the Magaliesberg in the background. And now I'm going to take you inside the visitor center. And you can see it talks about different aspects of evolution. It's pretty hands-on and interactive, actually. Kids love it. And of course, it has got a lot of skulls in it, which is exactly what you'd expect, right? And also reconstructions of human ancestors and with basic information about all of them. So what have we found there? Well, there are the human ancestors, but there are millions and billions of specimens of antelope, rhinos, elephant, basically representatives of all the fauna of the area that somehow got carried, fell, walked in, and trapped in the caves and fossilized. Of interest, all these there are 6 species here, and with the exception of that one there, let me tell you about them. That's Homo naledi, which was discovered in 2017, the latest. That's Homo erectus, which has been found all over Africa, plus Asia, plus parts of Europe, mainly Asia, Java. And this here is Australopithecus sediba, only from the Cradle of Humankind. Homo naledi, only from the Cradle of Humankind. That is Paranthropus robustus, using tools to dig up termites, only from the Cradle of Humankind. Australopithecus africanus, only from the Cradle of Humankind, and one other locality in South Africa in the Cradle of Humankind there. And this one here is Littlefoot, also only from the Cradle of Humankind. So of the 6 species found here, only one has been found in other parts of Africa and the rest of the world. So these 5 have only come from South Africa, just to give you an idea of kind of how rich this area is and how special it is if you want to understand human evolution. This is the famous Mrs. Ples. She belongs to that species there, and she comes from the Stagfontaine Caves. If you visit it, you can see the very site where she was found. She was blasted out with dynamite, which is why, if you look carefully, you'll see she has no teeth, a real tragedy. So that is Mrs. Ples. Right, and I think that's the end of my story. I hope I didn't bore you too much and you enjoyed learning something about South African geoheritage sites. And I'd personally love to find out about more of the sites that you have in India. I have visited them, and it really seems to be that it's a sad case that our geoheritage sites are not loved by the public as much as we love them. Thank you very much.
Thank you, Ian. It was a really wonderful presentation. And I think this subject, that is geoheritage, is totally neglected in, at least in our country. And because people, they know about biodiversity park and biodiversity, but they don't know about geodiversity and geopark, what is their aims. But geopark aims to protect geodiversity, which may include minerals, rocks, fossils, landforms also. They are also very important because it promotes geological heritage to the general public, as well as support sustainable economic development. So as Ian has shown that we can have geological tourism also, like guided tours or interpretation centers. So it was a wonderful presentation, Ian.
A pleasure.
Any questions you can ask on chat mode, so we can read. And Shankar sir saying excellent presentation. Mr. Auti is also saying excellent presentation.
Hello. Hello.
Hello.
Good evening.
Hi.
Hello.
अजित,
हाँ
मी एक दोन क्वेरी आहेत, विचारू का?
हाँ विचार ना विचार.
Request to everyone, only the person asking the question should unmute himself. Otherwise, others please remain mute in mute mode. Otherwise, it creates a lot of disturbances. Auti sir, vicharu sir.
Yeah. Dr. Ian, it was an excellent talk, very, very informative. Thanks for a good talk. I have got some couple of queries, not questions, just queries. While mentioning with regard to carbon-rich bands, that's in sandstone, my query is whether that carbon-rich band, whether it is fossilized organism like what we used to call as a unicellular organisms like eukaryotes or prokaryotes, or it is a inorganic carbon associated with that.
This isn't my field of expertise, hey? But as far as I know, the current interpretation of it is that it was formed by organic, by prokaryotes.
Yeah.
That's but I can't really debate it with you because I really don't know enough about that. I know that in the Witwatersrand, we also have carbon that's rich in gold, and they thought that that was prokaryotes, sort of mats of bacteria that the gold got trapped in. But I think my understanding is now more people believe that it's inorganic. It seems to be quite a difficult thing to decide.
Yeah, that's what in the Witwatersrand there is a gold, uranium, and that carbon. They occur together. We call it as a carbon mesh or organic mesh or some sort of this thing. And there is one uranium mineral named after that. That is called thucolite. Thucolite.
Wow.
That is That is the only mineral we got it from the South Africa. That is called in Witwatersrand, thucolite, THUCOLIT. That is thorium, uranium, carbon, like that. My second this thing was with regard to how you pronounce that is a Vredefort or
Vredefort.
that
Vredefort.
dome.
Yeah, yes.
There is some this thing pronunciation. While it is impact structure, it is referred to as a dome. Yeah, this is why it is called dome and not a crater. That is one. And is there any impact? It has gone on the, I think on the western side of this dome, there are some gold, uranium and gold mines are there. Are there any those rocks in the quartz pebble conglomerates affected by these impacts? That's
Again, this isn't sort of my field of interest, but there must be because actually that Vartasrant basin is very deep. And I think because of that impact, they were caused to dip, which meant that they actually became shallower towards the Witwatersrand and accessible at the surface. So as far as I know, it's because of that impact that we were able to mine gold quite shallow in the Witwatersrand. Otherwise, it would have been much deeper. But beyond that, I'm not going to say a word because I might mislead you.
Oh, thank you.
सुधीर मला वाटतं मोहाबे सरांना काय
मोहाबे सरांना अनम्यूट करतो. मोहाबे सर, I am unmuting you. Request to unmute. Mohabe sir.
Ian, Dr. Mohabe is actually responsible for a very important site in India about dinosaurs. And
really?
He is very much instrumental in making it a Geo-heritage site.
Wow, okay.
Yeah, so he has to talk to you. Question.
Mohabe sir? Am I audible, Vartak sir?
Yes, you are.
Yeah, okay. Congratulations, Dr. Ian, for a very wonderful and well illustrated talk. And it was a real journey to many geosites, right from very old, almost 3.2 billion years to 5 million years. It is very interesting. But just I wanted to ask you, of those very interesting geosites, how many of them they have the recognition as a UNESCO geoparks?
For me to tell you off the top of my head is quite difficult. So the Vredefort Dome is a UNESCO World Heritage Site. The Barberton is a UNESCO World Heritage Site. Cradle of Humankind is a World Heritage Site. Okay. Then you've got the Drakensberg World Heritage Site. And as far as the Geoheritage sites, I'm not sure. I don't know. I don't think we have many. I mean, we tend to sort of go for the World Heritage status here, but I could be corrected. It's something I'll have to find out.
Okay. Thank you, Mike. Because I'm asking you in the context that in India, Geological Survey of India, there is some sort of a nodal agency to declare the important geological sites, what they call as a geological monuments, national geological monuments. And as you correctly pointed out, in the very beginning of your lecture, there are certainly 32 national geological monuments declared and notified by Government of India, that is through Geological Survey of India. And these include not geological sites of importance, but also many paleontological sites, right from the Archean to you can say up to Paleocene.
Wow.
But none of these sites, they are so far able to get recognition as a UNESCO recognized geoparks.
Wow, okay.
And as Dr. Ajit also pointed out, and that is the great worry for us, though we have got such a precious geological treasure, but none of the sites in India has so far they have earned any distinction of being a UNESCO geopark, and that we are striking for that. We have wonderful dinosaurs sites, not only from the Jurassic and Triassics, that means around 240 to 250, but also wonderful sites, what we call from the late Cretaceous. Very good graveyards of both sauropods and theropods, and also their hatcheries. And government of Gujarat, they have taken a lead in establishing a fossil field museum there, dinosaur museum, that is unique in India. And they have also taken up excavation and developing this dinosaur geopark. And we are making all the efforts to see that at least this site get recognition as a geopark, that is, as it qualifies all the criteria as defined by the UNESCO for any application for getting recognition as a geopark. Thank you so much, Dr. Ian. Thank you.
Ian sir, Abhishek Kumar sir has asked one question. In one of the slides, you talked about mountain range higher than Himalayas. Can you please throw some light on it?
Yes, when Pangaea or southern Pangaea or Gondwana land was being formed, it was the Antarctic peninsula that kind of collided with Africa, and there were all these sediments in between forming the Cape Fold Mountains, which are still pretty impressive. But 260 million years ago, they were huge, and they estimated to be as high as, or even higher than, the Himalayas way back then. If you have seen a picture of Cape Town, you'll see Table Mountain today. That's kind of one of the ancient remnants. And we actually still have earthquakes every now and again in the Cape from the release of stress from that really, really ancient mountain building event.
Thank you. Ajit?
Does it help?
Hello. Can I just make an observation?
Yes.
I'm Dr. S.K. Wadawan. Hello.
Hello.
Hi, yes.
Can I just make some observations? I'm Dr. S.K. Wadawan.
Okay, sir. Sir, please.
Yeah. Okay. Yeah. Thank you. Thank you, Dr. Ian. Actually, during 35th IGC, which was organized by South Africa at Cape Town, there was a very special session on geoheritage sites, and one beautiful compiled book on Africa's top geological sites. I have purchased that, and it's a very nice compilation of 44 such geoheritage sites in Africa. And Professor Richard Viljoen and his team, they were very active. Yeah, they were very active in discussing and proposing many more of such sites. And of course, wonderful world-class spectacular sites are there in not only South Africa, but other parts of African continent. And of course, we really appreciate the kind of dedicated efforts which your teams have been making. Similar efforts we also have been making, as my colleague and friend Dr. Mohabe just mentioned, to get many of our geological monuments declared as geoparks. Some of them, they deserve to be declared as geoparks because they have all the credentials and all the requirements. Now, the only difficulty is that initially we need to have some legal protection for the protection and conservation of these geological sites. Number two, we need to have involvement of tourism department, because this is not purely a geoscientific activity. If people are to be attracted towards this, we really need to have a very dedicated program wherein tourist operators are involved and they are also guided to promote and to manage these sites. Because if we have increased footfalls, this may also create kind of a damage and risk for their loss. Many of the sites in India which are geological sites, we have seen many of the fossils, they are just excavated, extracted, and they are just taken away in a clandestine way. And many of the local people also are involved in this. So they in fact sell some of these fossils, particularly in Jaisalmer I have seen, in Rajasthan. So both dangers, unless we have some legal protection, and also such protection wherein we can punish those who are doing this kind of vandalism and destroying these sites. We are in the process, I can assure you, and we are following all the very good practices including those that you are following in South Africa. So thank you very much for all this excellent presentation.
A pleasure. A pleasure.
Sir,
Yeah.
Ian, sir.
Yes.
HMS Prakash sir has asked, the volcanic bombs you mentioned could be, I can't pronounce it properly. Yeah.
Hyaloclastic. Hyaloclastic or orbicular structures, single shelled.
That could be. I think they just part of, the name has slipped from my mind. It's just, if they're above a certain size, you call them volcanic bombs, right? Yeah. And then underneath that, well, just popularly, we talk about volcanic hail. But I'll have to think of the name, but I'm sure you're right. I'm sure you're right. Yeah.
One more question by Dr. Kadale. He's asking, could you please tell us more about the human species from the Cradle of Humankind, and how is it different from other parts of Africa?
Yes, well, so obviously here in South Africa, we aren't the only site that has, the only place that has hominin finds, hominin fossils. East Africa, Tanzania, Ethiopia, Kenya, even some in Chad also have them. But in East Africa, they're mostly associated with the rift valleys. So when the rift valleys were being formed, you had these hominins walking around and becoming preserved in the sediments there. Ours are different because of those dolomites that became dissolved by the acid rain forming the caves. And then the hominins either fell in by mistake or were carried in by predators, and all the other animals as well that you find there. You get lots of owl pellets, for example. And that is why we're so rich in fossils, because of the dolomites forming those caves. And does that answer your question? So,
thank you.
Yeah.
Wonderful. Excellent, excellent talk.
Wonderful. Great.
Shankar sir, would you like to say something?
कोणाला unmute करू अजित?
Shankar sir ने कर एकदा.
Yeah. Well, whatever I wanted to say, I put it down in the chat.
Yeah, that is there. But if you say a few words, that will be nice.
Yeah, it was very nice to listen to Ian. He made a nice presentation, and there are some good takeaways for any country that wants to promote geoparks and geotourism. There are excellent ideas, and I wish India will also, come up with nice geoparks. We have great potential, but it has to happen someday, and I only hope that it will happen sooner than later. Thanks, Ian, for your wonderful presentation.
A pleasure, a pleasure. And I was just thinking, my interest really, it's so hard to develop them, to attract visitors to them and manage them. That Kitching Fossil Exploration Center, we've been working there for 15 years. We have about 5,000 visitors a year there, but to sustain it and to keep and to employ people and to make sure that they do what they're meant to be doing and that the whole place is working is an incredibly hard amount of work. It takes a lot of management, and it's made me realize how difficult it is to make a sustainable kind of site and to employ people, manage it, and develop it so that it's more than just a place.
Now I request Dr. Ajit Vartak to thank Ian sir. Dr. Ajit Vartak.
Thank you, Ian. It was a really wonderful talk. And I had the opportunity to visit Cradle of Humankind during our 2010 conference organized by you. That organization also was fantastic. I've seen so many people from different 35 countries they came, and the way you organized that conference, it was really, that gives that. And you're a very good speaker also, very good teacher and popular teacher I've seen there. Thank you very much for accepting our invitation and giving this wonderful talk. Tomorrow we'll be celebrating Fossil Day, and tomorrow we'll have a talk by Dr. Dhananjay Mohabe, and he'll be talking about Indian dinosaurs. Just now he talked about dinosaur interpretation park in Gujarat. So he is the instrumental person behind that. So tomorrow he'll be talking about Indian dinosaurs at 6 p.m. We will be meeting again tomorrow on the Zoom, and the link and everything will be given to you. So we'll meet tomorrow 6 p.m. for Fossil Day.
Yes. Thank you, Ajit.